Okay, I'm going to set up here a MedCalc review, and we're going to talk about how to answer these questions. They're pretty complex. The first thing we want to do is how to approach complicated questions, especially the ones that you're getting for critical care. First, you want to look at the final question to determine what the question should look like, the units, what they should be like, milligrams or micrograms per kilogram per minute, or what is the question asking, the final question asking for. The second thing you want to do is identify the parts of the question. What do you have? You know, what drug do you actually, how much do you have it and what's the concentration? What do you want to give the patient, and what are the conversions you have to do? And so what we'll do is we'll start with what you need, which is the end of the question. You will need milligrams or micrograms per kilogram per minute or whatever, but we'll see what you need. We're going to add the dosage and the rate, and then we'll do the rest of the parts to get the answer. And when we do that, we're going to do it in such a way that we're going to be able to cancel out the units we don't want on both sides of the equation. I'm going to demonstrate that in these questions. So here we have nitroprusside or nipride, 500 milligrams and 500 mils of D5W running at 5 mils per hour for a 110-pound patient. How many micrograms per kilogram per minute is the patient receiving? Well, we're going to pay attention to this part right here. Okay, that's what we want. That's the final thing, what we need. Say what we need. Okay, we need micrograms per kilogram per minute. This is what we have. Okay, we've got nipride, 500 and 500. Okay, so this is what you have. And this is what your dosage, what you want, what you're going to be giving the patient. So this is the dose. Okay, and we need to pay attention to that too. Also, because we got kilograms in here, we have to pay attention to the patient's weight. So we need to do a conversion, at least one, actually two, because we have milligrams here, we have micrograms here. All right, so the first thing we're going to do is say X, and let's start at the bottom here. We'll go X is equal to blank micrograms per kilogram per minute. Okay, that's what we want to see when we're finished with this. So the first thing we're going to do is we're going to get the patient's weight. Let's do the conversion here. Patient is 110 pounds. And we'll times that by 1 kilogram over 2.2 pounds. And we're going to get 50 kilograms. Okay, so we know that this is what the patient weighs. And then what we have is, is 500 milligrams in 500 mils. Okay, so we could cross these out and say we have 1 milligram per mil. Now we need micrograms in this answer that we're trying to get, so we have to change that to micrograms. So let's go 1 milligram over 1,000 micrograms. Okay, so we'll cross that out, and that's going to be equal 1,000 micrograms per ml. Okay, so that's what we have. Okay, your patient is 150 kilograms. You have that much. Now here's your dose up here, and we've got to fix the dose to be able to fit into this. So your dose is 5 milliliters per hour. Okay, we have lots of things we have to change with this, but this is what we're actually giving. Okay, 5 milliliters per hour. Now we're going to hang on to hours for a little bit because sometimes the numbers can get crazy when we get into minutes. We'll do minutes last. Okay, so we know we have 5 mils per hour, so we're going to do what we have. Okay, so we want to cancel out the milliliters, so we're going to put milliliters. We're going to say 1,000 micrograms per milliliter. So we cross that out, we cross that out, and the dosage here is actually 5,000 micrograms per hour. Okay, and so we also have micrograms per kilogram per minute that we want the final answer to be, and since we are giving 5 mils per hour, which ends up being 5,000 micrograms per hour, we need to divide that by what the patient weighs. So this is the total of what they're giving. We want to see how much per kilogram they're giving. So we want to say, all right, 50 kilograms. So we're going to say, let's see, 5,000 divided by 50. Okay, so we can do that. 500 divided by 5 is going to be 100 micrograms. Okay, and then we can say per hour. Okay, and what we did here is we took the weight, we took the total dose in micrograms per hour, and we divided it by the weight. So they're getting 100 micrograms per kilogram, okay, per hour. We can do it like this. And 500 micrograms per kilogram per hour. Now we need hours to minutes. So we need to do 1 hour over 60 minutes. So we have 100 micrograms. 100 micrograms divided by 60, which is going to be 1.67. Okay, 1.67 or 1.7. And that's your answer essentially, because we've now changed, we've got micrograms per kilogram and we've just changed hours to minutes. So that is 1.7. That's your answer right there. Okay, we'll do more of these. So now we have nitroprusside 200. This is what we have up here. This is what we're giving, and this is our patient, and this is what we want. So we have this thing, we need all of this in here as well. So we start out with X is equal to blank micrograms per kilogram per minute. Okay, so we know that this 140-pound patient, let's start with, actually we start with the patient. Okay, the patient is 140 pounds. And we want to divide that by, or multiply, see, 1 kilogram over 2.2. We just divide it by 2.2 to get, cross out the pounds, and we get 140 divided by 2.2. And that's 63.636363. 63.63. And that's good enough. So we'll just say kilograms like that. Okay. And now what we have is 200 and 100. Okay. So we have 200 milligrams over 100 milliliters. And we have, and we need to have micrograms. Okay, so let's do this. We're going to go like that and say, I'm going to erase that a minute. Cross out the zeros, and this will make your math easier. This is 2 milligrams per ml. Okay, and if we want to change it to micrograms, you'd go 1,000 micrograms in 1 ml, or 1 milligram. Okay, so we cross the milligrams out, and we get 2,000 micrograms per ml. Okay, and that's what we have. The patient weighs 63, and we have 2,000 micrograms per ml in the bag that we're hanging. Okay, so now we need to figure out how many micrograms per kilogram per minute we're giving the patient when we're infusing it at 4 mils per hour. So here's the infusion. We're giving 4 milliliters per hour. Okay, so we'll start by adding what we have. Okay, so we have 2,000 micrograms per ml. Okay, mLs. We can cross out the mLs. We got micrograms per hour. We can keep going, and we can say 1 hour divided by 60 minutes, because we need minutes. Okay, so we can cross out hours here. And now we have the kilograms. Okay, that's the tricky part that makes this backing. We're actually backing up through this question. So let's just do micrograms per minute for a minute here. Okay, so we have 8,000 micrograms. Okay, in over 60 minutes. Okay, so we cross out one here, and we got 800 divided by 6. And 800 divided by 6 is 133 forever. Okay, so that's equal to 133 point, we'll just say 33. Okay, so that's micrograms per minute. Okay, and this is what we're actually giving. So we still have to divide it by the kilograms to get the answer. Okay, so here we go with 133.33 micrograms per kilogram, or per minute, excuse me. And then we need to divide that by, okay, divided by 63.63 kilograms. And that's because this is what we're given total. We need to divide it by how much the patient weighs in order to get a weight-based answer. Okay, so we take 133.33 and we divide it by 133.33 divided by 63.63, and the answer will be 2.095, okay, which is 2.095, and a whole bunch of numbers after that. So that's going to be 2.1 or just 2, but that's your answer right here, 2.1 micrograms per kilogram per minute. So basically what I did here was we looked at how much the patient weighed in the beginning. We looked at what we're actually infusing into this patient, and we got it down to micrograms per mil. And then we took, micrograms per minute actually down here. So we looked at what we actually are giving, we look at what we have, and then what we're actually giving here at 133.33, we have to divide it by the weight, micrograms per kilogram. So this is how many micrograms per kilogram we're actually giving this patient. So the answer is 2 or 2.1. And we'll do this again. Dobutamine, 500 and 500, 1.5 mics per kg per minute for a 50 kilogram patient. What is the rate? This is a different kind of question. What we want are milligrams or milliliters per hour. Milliliters per hour is what we're looking for. Okay, so the patient we know is 50 kilograms. What we have is basically 1 milligram per mil of this patient. So this is what we have, and this is the patient, and this is what we want, and this is what we're infusing. Okay, so let's start with where, what we're infusing. What we know that we want, see, X is equal to blank milliliters per hour, okay, per hour. So we're giving, see, we'll start with what we have. We have 500 over 500, see, milligrams per mil. So that's going to be 1 milligram per mil. And if we need to do a conversion, which we do, because you can see here we've got micrograms, and we can't deal with that until we change to micrograms, we're going to go 1,000 micrograms, okay, divided by 1 milligram. So we cross out the milligrams, and we get 1,000 micrograms per ml. Okay, so that's what we actually have in the bag. We're infusing it at 1.5 micrograms per kilogram per minute for a 50 kilogram patient, 50 kilogram patient. All right, so infusing. Okay, we start with 1.5 micrograms per kilogram per minute. Okay, we're going to ignore minutes for a minute. Okay, so we'll start with 1.5 micrograms per kilogram. We've got 50 kilograms. Okay, 50 kilograms. And then we have, and this, remember, that's what the patient weighs. And this is what we have in the bag over here. So then we'll do this as well. We'll say 1 milliliter divided by 1,000 micrograms. Okay, now I flipped this because we want milligrams per hour, or milliliters per hour. And so we don't want micrograms, but we need to work them out. So we have kilograms, and this is what we have. Okay, we have 1.5 times 50, 1.5 times 50 is 75 over 1,000. Okay, and that's going to be milliliters, and it will be per minute. Okay, because we started over here with minutes. We ignored minutes for a few minutes, and now we're back to having the minutes. So this is mils per minute. So if we take 75 and we divide it by 1,000, I bet you know what the answer is, right? We just move the decimal place over 3 times. Like this, 1, 2, 3, and there's going to be a 0 here. So that's going to be 0.075 milliliters per minute. All right. So then we take this, let's see here, milliliters per hour. We need to change minutes to hours because we started up here with minutes. Okay, that's minutes right here. So we take this and we go 0.075 milliliters per minute times 60 minutes per hour. Cross out the minutes, then we get our crazy number that looks like it's insane, 0.075, and we multiply it by 60, and we get 4.5. Okay, equals 4.5, and that's actually the answer, 4.5 milliliters per hour. We've just converted this to hours, so this is milliliters per hour, and that's what we set the pump at. Okay, that's the pump rate. All right, so we'll try this again, and we have Dobutamine. This is what we have, 200 milligrams and 250. We're infusing it at 6 micrograms per kilogram per minute. We have a 75 kilogram patient, and we want milligrams per or milliliters per hour. Okay, so we say X milliliters per hour equals what? Okay, so what do we have here? We got a 75 kilogram. Let's see if I could do that here. Circle, that's the patient. What we have is up here, which is 200 milligrams and 250 milliliters. And we can, we can cross out a 0 here, and we've got 20 over 25. You know, 4 times 5 is 20, and 5 times 5 is 25. So you can go 4/5, and that would be milligrams per ml. And that would even go to 0.8 milligrams per mil. We know we want micrograms, so let's do that. Let's go 1 milligram is 1,000 micrograms. Okay, so we have 1,000 here. So if we're going to convert 0.8 to 1,000, let's do that. 0.8 to times 1,000. We're going to go 1, 2, 3. And so we have 800 out of this whole thing. We have, and I'll show you, my milligrams cancel out. This is equal to 800. So here we have 800 micrograms per ml. And that's what we have in the bag. Okay, we have that in the bag. This is what we're infusing now. We need to figure out what we're infusing. So we're infusing 6 micrograms per kilogram. Remember, we're gonna ignore minutes for a minute, and then we'll come back and get it. Okay, we want milliliters per hour. We've got micrograms per kilogram. So let's do this, and we have 75 kilogram patient. We know we need kilograms. So that would be 75 kilograms. Okay, we kill that, and that's how much we're actually getting per minute. Okay, so we go 6 times 75, and we get 450. 450 micrograms, and now we're going to get the minutes back up here, okay, per minute. Now we know we want hours, okay? We want hours in our answer. So we need to do this. We need to go 60 minutes is 1 hour, okay? We do that, we can cross out the minutes, and we've got 450 times 60, which is 27,000. Okay, 27,000 thousand micrograms, not milligrams, over an hour. Okay, we're giving 27,000 micrograms in an hour. Now we have, let's see, milliliters per hour. We need to go back to what we have. Okay, what we have here is, this is what we have. Okay, we have this here, that's have. This is the infusion, so we're infusing 27,000 micrograms. So let's take what we have, desired over have. So let's do 27,000 micrograms. That's what we're infusing per hour, times, and then we have to fix this so we can get milliliters at the top, so we're going to flip it. Okay, so that's milliliters over micrograms, 800 micrograms. We can cross out 2 zeros here and 2 zeros here, and we get 270 divided by 8, which is 270 divided by 8 is 33.75. Okay, and that's going to be milliliters per hour. Okay, and so your answer could be 33.8 or 33.75, or it could be 34, depending on what the rounding factor is. So let me erase this thing here, and let's look at what our answer is going to be. So we're going to take answer here equals, and if you're not sure and it's a paper test, write all of them. Okay, so we have 33.75 mils per hour, or 33.8 mils per hour, or 34 mils per hour. So we've done all the rounding here. And remember, anything that's 5 or higher, you round up to the next number. So like 33.5 would have been 34, but if it was 33.4, you stay where you are. It's 33 for the rounding. Okay, so just remember that when you're doing your rounding. So here we go again. Here's what we have. Okay, and this is what we're infusing. This is what the patient weighs, and this is what we want to get at the end. So this one's going to be tough. Okay, so we have a patient who weighs 47 kilograms. I'm going to circle that. We have 250 over 250, so we could actually say we have 1 milligram per mil of dopamine in the bag. The infusion is 52 milliliters per hour, and what we want is micrograms per kilogram per minute. So this is actually what we're putting in the patient, okay, actually flowing. Okay, so we have to divide that by the kilograms, because this is actually what's going into the patient, 52 milliliters per hour. Okay, so this is, like I said, this is half, and this is what we're giving them, and what we want to know how many mgs per kg we're giving per minute. So let's start with the flow rate. 52 milliliters per hour. Okay, we want minutes actually, but we'll come back to that. Okay, we know that we're giving this much milliliters per hour per kg. Let's see what we have. Let's start with what we have. Okay, so let's say we're going to do this 1 milligram per mil. Okay, and that's just to keep it simple. Cross out the mils, and we're actually giving 52 milligrams per hour. Okay, that's a good start. We know we need micrograms and kilograms and minutes. So let's do that. So we have we're giving 52 milligrams per hour. So how many milligrams per kilogram are we giving? Let's go ahead and turn this into micrograms. So let's go 1,000 micrograms divided by 1 milligram. Okay, we cross out the milligrams. We're actually giving 52, let me do this, 52,000 micrograms per hour. Okay, we still have to get to minutes, but we're here. Okay, so we're going to take 52,000 micrograms, and we want to know how many micrograms per kilogram, right? So we're going to take that number up here and we're going to divide it 52,000 by 47 kilograms. And that's going to get us what number? Let's see. 52,000 divided by 47, which is 1,000, okay, 106.38. And that would be micrograms per kilogram. Okay, it's a lot. And so, but now we've ignored hours. Okay, so we're still at hours. We still have to convert to minutes, but we did kilograms here. So let's just, we can assume now that this is micrograms per kilogram. And so we're going to go per minute or per hour. We're still at per hour. So we need to go 1 hour divided by 60 minutes. And so now we're going to take that crazy number, 1106.38. Okay, 1106.38, and we're going to divide it by 60. And we're going to get 18.439, which is 18.44. Okay, so that now we've got it to minutes. We got rid of hours, and that's actually our answer. We have 18.44 would be micrograms per kilogram per minute, or 18.4 or 18. Okay, it would be micrograms per kilogram per minute. And this is kind of confusing, but if you think about it, we just divided this by the number of kilograms of the patient, and that's how we got the number of kilograms, micrograms per kilogram. We took it for 47 kilograms times 1106, we got 52,000. And so then we converted hours to minutes, and that's how we got our answer. And if you're not sure, give all of them. Okay, we've got 1844, 8.4, and 8 micrograms per kilogram per minute. And that's how you do that. And now this next one we have, again, we look at what do we have? We have 500 and 200. We're running it at 22 mils per hour. There's your rate. Okay, your patient weighs 37 kilograms. We don't have to do any conversions there. We want this crazy number right here. Okay, so what we have here is 500 over 200, okay, which is basically 2.5 milligrams per mil. Okay, so that's what you have. And we have the rate here, and we have how much the patient weighs, and then what we want, milligrams per kilogram per minute. Okay, we got hours here, and we got minutes here, so we need to pay attention to that. But first, what we're going to look at is, we'll start with 22 milliliters per hour. And now we're going to look at what we actually have in the bag. Okay, times, we have 2.5 milligrams per ml. Okay, so we go 2.5 milligrams per ml. And then we want hours to minutes. Actually, let's not jump ahead too much. 22 times 2.5 is going to be 55. Okay, so we actually have 55, nice whole number. That's milligrams per hour. And so now if we want to convert to micrograms, we're going to go with 1 milligram underneath and 1,000 micrograms at the top. So that's going to give you an easy number of 55,000 micrograms. We cross these out per hour. The next step we want to do is find out how much per kilogram we're going to get. Okay, so we say, all right, 55,000 micrograms divided by 37 kilograms. And so you have, let's see, 55,000 divided by 37, which will give you 1,486.49. And that's micrograms per kilogram. And this is per hour. Okay, we need minutes though, don't we? So let's look at minutes. Okay, we've done we've done all of it so far. So we look at 1,486.49. This is micrograms, not milligrams. Micrograms per kilogram per hour. We need to do minutes now. 1 hour is 60 minutes. Okay, so then you take that god-awful number and you divide it by 60 and get a little bit better number. 1486.49 divided by 60. And you get 24.7748. Okay. So basically, this is going to be 24.8 or 25. Okay, 25. That's going to be micrograms per kilogram per minute. Okay, so this is what we did in recap. We started out with the rate and we multiplied it by what we have. And we got what we're actually giving the patient. Okay, we're actually pumping this much into the patient. We want to know how many kilograms, how many micrograms per kilogram we're pumping into the patient. So this is this is a number we're sticking with. We're not raising or lowering it. We need to know, we need to divide it by 37 in order to know how many micrograms per kilogram. So that's your micrograms per kilogram, but it's still hours. So then down here, we did micrograms per kilogram per hour and converted to minutes to get 24.8 or 25 micrograms per kilogram per minute. Let's do another one. We have 200 over 200, which is going to be a nice, easy 1 milligram per ml. You can see that these cancel each other out. The infusion is 10 mils per hour. Patient weighs 52 kilograms. We want micrograms per minute. Well, micrograms per minute does not require that I know how much the patient weighs. So we can ignore that. Okay, so basically we want to know what we're giving. So let's start with the infusion. Okay, this is the infusion here, and that's going to be 10 milliliters per hour. Okay, this is per hour. Okay, and then we have what we have. Okay, we have milligrams per mil. So let's flip that, or actually we don't have to flip that. That's 1 milligram per ml. We can cross out that and cross out that, and now we've got 10 milligrams per hour. But we need minutes and we need micrograms. So this is going to be a big conversion thing. Okay, so 1 milligram underneath 1,000 micrograms. Okay, so we know milligrams have been crossed out. We need minutes, not hours. So we're going to do 1 hour over 60 minutes. And that's going to be your answer, basically. So we could actually cross out this and say we have 1,000 divided by 6, which is going to be 1,000 divided by 6 is 166.7 or 167, and that's going to be mics per minute. Okay, micrograms per minute. So this is what we did. We took our flow rate. Okay, that's the flow rate, and this is what we have. Okay, we took what we have in the bag. The nitroglycerin, 200 milligrams and 200 mils is 1 milligram per mil. We converted micrograms. Okay, convert milligrams to micrograms. And then here we converted time. Convert hours to minutes. And that's where we got 167 micrograms or 166.7, depending on, you know, what your pump does, essentially. But if you're in a paper test, write both of these out. If you're not sure, put both answers out. So here we got another one. And we have, this is what we have. This is our flow rate. This is the weight, and this is what we want. Again, we don't need to know this because there's no weight in here at all. Okay, and we're giving it milliliters per hour. So let's start with the flow rate, 1.5 milliliters per hour. Okay, and so we have hours. We don't have to do anything with the time. Okay, and we also have 250 milligrams in 100 mils. Okay. So you could just put that in there and just multiply it. 250 milligrams divided by 100 milliliters. So you can cross out the milliliters. You want milligrams per hour. You got milligrams per hour. That's you've got it. All you have to do is the math now. So we do 1.5 times 250 and divide that by 100. And we get 3.75. And that would be milligrams per hour. Okay, or 3.8 milligrams per hour, or 4 milligrams per hour. Okay, you've done all of these. This is with 3 significant figures, 2 and 1. Okay, if you need a whole number, there's your number right there, but all these answers are correct. So we go and do another one like this. Okay, we have 200 over 200. You know that you can cancel these two out. This is what you have. Okay, so that would be 1 milligram per ml. Let's not do that real quick. Okay. All right, 1 milligram per ml. We're infusing at 8 mils per hour. We want milligrams per hour, so we don't care how much the patient weighs. So we start here with the rate. Okay, this is the rate, the flow rate. We're going to go 8 milliliters per hour. And so we have the time, and that's check, that's good. And now we know what we have, so let's do 1 milligram per ml. Okay, we cross out the mLs. Okay, this is what we have. This is the rate, and that's what we have. And so we have milligrams per hour. And that one's also good. Check. So we have 8 milligrams per hour. And that's your answer. Okay, that's all you have to do with that one. Amiodarone, I love this. We have 100 over 100, so you can say, all right, I have 1 milligram per milliliter. That's what you have. Over 10 minutes, got to give it. Okay, so that's 100 milligrams to be given over 10 minutes. The patient weighs 50 kilograms. What rate should the pump be? There's nothing here about weight, except that you're telling how much the patient weighs. So you really don't need to do that. We need to know what the rate is going to be. So we're going to give 100 mils over 10 minutes. Okay, so that was simple. 100 mils over 10 minutes. Okay, you can cross that out. So that's going to be 10 milliliters per minute. Okay, do I need hours? Maybe. If you need hours, go ahead and do them. Okay, 10 milliliters per minute times 60 minutes per hour. Okay, that's going to be 600 milliliters per hour. Okay, but you're giving it over 10 minutes. So it's not likely you're going to give it over hours. Okay, it's just on the technical note here. You know you're giving it in less than an hour, so this is not really useful. But if you have a pump that only does mils per hour, it might be useful. But this is your answer essentially. And if you need to convert it to hours, that you've got this one. Okay. So now we're going to do amiodarone 200 and 100. Okay, so that would be 200 milligrams in 100 mils, which is equal to 2 milligrams per ml over 10 minutes. So this is a bolus, weighs 75 kilograms. What rate should the pump be set? Okay, we don't care about this because this is not a weight-based calculation. So we're going to give 100 mils, once again, 100 mils over 10 minutes. So we just do 100 divided by 10, which is 10 mLs per minute. And again, if you need hours, you can just multiply it by 10 mLs per minute times 60 minutes per hour, and you're going to get 600 mLs per hour. Okay, but this is the one you want because you're only giving it for 10 minutes, so you don't care about the hours very much. All right, so we have digoxin. IV push. This is what we have. This is what we desire. Okay, desired over have. And that's your volume. Okay, volume is one milliliter. What volume of medication should be given? So we just go desired over have times volume. That's going to be 0.25 divided by 0.5 times 1 milliliter. Okay. So you take it and you go 0.25 divided by 0.5, which is going to be 0.5. Okay. 0.5 times 1 ml is going to be 0.5 mLs. And that's your answer. All right. We have another one like this. Okay. Desired over have times volume. Remember, D over H times V. So we have 0.5 over 0.1125 times 1 mil. Okay, these cancel each other out. They're units, so that's milligrams and that's milligrams. So if you're wondering, that's fine to do it like that. So we have 0.5 divided by 0.125, which is going to be 4. Okay, so 4 times 1 mil, 4 times 1 mil is equal to 4 mils. Okay, so that's how much you're going to give IV push. This is one dose. It's a bolus. Okay, IV push equals a bolus. It's one injection. Okay. All right, so then we go on to the next one. We have 15 milligram tablet. And we have, I mean, that's what we want to be giving. That's ordered. So that's going to be desired. This is have, and it's scored. So it can be divided. How many tablets or parts of tablets with somebody weighing 84 kilograms? Well, we don't care how much they weigh because we already have desired and have. And the volume is tablets. So we go D over H times Q. That's going to be any volume, whatever it is. So we're talking 15 milligrams over 30 milligrams times 1 tablet. Okay, since it's not volume, but it's a tablet. Okay, so we cross out the milligrams, and we get 15 over 30, which is 1/2, 0.5 tabs. So you're going to give half a tablet. There's your answer. Okay, the next one we're going to do is 37.5. Okay, that's your desired. This is what you have, and that's your volume, basically. Or, and we don't care that they weigh, because how many tablets will be given to a patient that weighs this much? It's not weight-based, so we don't care. Desired over have times tablets. Okay, 37.5 milligrams divided by 75 milligrams times 1 tablet, because this is 75 milligrams per tablet. Okay, so that's your actual volume, or what how you're going to give it to the patient. So you get 37.5 divided by 75, which is actually 0.5 tablets. Okay, and that's because we cross these guys out. They're the same units. So that's your answer, half a tablet. And now let me not skip so far ahead. We have 20 milliequivalents liquid by nasogastric tube is ordered. Okay, pharmacy sends 20 milliequivalents in 15 mils. So we've got volume, we've got what we have, and we have what we want. So that's desired, this is have, and that is volume. We don't care how much this patient weighs. This is not weight-based. They're not, say, like milligrams per kilogram per minute. So we can ignore that they're 65 kilograms. So we start with desired over have times volume. This time we actually have a volume. So we have 20 milliequivalents and 20 milliequivalents, okay, in 15 milliliters. Okay, we can cross that out. We got 20 on both sides. And so basically what we're going to do is give 15 mLs. Okay, 15 milliliters is your answer. Very simple question. Now we have something a little bit more complex. Same idea. How many mLs should we give to a patient weighing this much? Well, we don't care how much. They could be 4,000 kilograms. It doesn't matter. The order is to give them 35 milliequivalents in the NG tube. the pharmacy is giving you 20 milliequivalents per 15 mLs. So we have to figure this one out. Okay, so that's desired. That's making me move things around again. This is desired, and this is have, and this is volume up here. Okay, so we have all of it here. Desired over have times volume. We have 35 mil equivalents divided by 20 mil equivalents times 15 mils. Okay, so we cross that out, and then we have see, that's 7 times 5, and that's 4 times 5. So we can go 7 and 4, and then 7 times 15 divided by 4. That's one way to simplify your math. So we have 7 times 15 divided by 4, which is 26. Okay, 26.25 mLs. So let's look at this again. Okay, we had 35 over 20 times 15. If we didn't do any of that stuff that I did, we go 35 divided by 20 times 15 is still going to be 26.25. Okay, so it's nothing fancy that I did. It's still the same thing. That's always good to check yourself. But if you want tenths, 26.3, because this rounds up. Okay, so that would be mLs. So either 26.3 or 26.25, or it's just going to be 26 if you need a whole number. Okay, and sometimes you do, but if you have an oral syringe, you can sometimes give the amount that you need to give in there, you know, with a reasonable measurable fraction. So we have a patient who weighs 230 pounds, about to receive a heparin drip at, okay, here we go. Here's the rate. And the standard mix is this. What rate will be set on the infusion pump? Okay, that's what you have. It's a little bit different. Okay, this is your rate. So we're not figuring out what rate. We want to know how are we going to run this on the pump? And this one's in pounds. So let's start with the patient. Okay, patient weighs 230 pounds. So then we're going to multiply 1 kilogram divided by 2.2 pounds. And we're going to get 230 divided by 2.2. We're going to get 104.5454545454 forever and ever. Okay. So we can actually round that and say 104.5. Okay, that's kilograms. Okay, and then in adults, you can do that, and in children, you should probably do 2. You do 10,000, especially small children. You would do, in 100s, you do 104.55 if it was a child. Okay, but since it is an adult, we're going to do 104.5. And so we know we have this 25,500. So let's do that. We have 25,000 units and 500 mils. We can cross out 2 of these and 2 of these. We got 250 divided by, 250 divided by 5. Okay, 250 divided by 5 is going to be 50. Okay, because 5 times 5 is 25 plus 10 is going to be 50. So we have 50 units per ml. Okay, that's what we have. And this is the patient. They weigh 104.5 kilograms. So now we know the rate is 18. Rate is 18 units per kilogram per minute, or per hour, excuse me, per hour. So let's look at this for a minute, per hour. We're going to ignore time for a minute. We're just going to say, okay, 18 units is what we're giving per kilogram. So we know we have to do 18 times 104.5 to get how many units per kilogram we're giving them, because it's 18 units for each kilogram in that person's body weight. So we have to multiply them. So 18 times 104.5 is going to be 1,881 Okay, 881. Units can be crazy, you guys. This is how it is. They're in the thousands a lot of times. So that's units. Okay, 18 units per kilogram. That's how many units we're giving per hour. Okay, so units per kilogram per hour. That's the answer. So what's the rate we want to give it on? So we have 50 units per ml. Okay, so the rate on the infusion pump, usually it's going to be something like mils per hour, okay, or mils per minute, or milligrams, or whatever. So we're looking for mils per hour, essentially, when we're talking about what rate to set the infusion pump to. But we've got this. This is the dosage we want to give, but we also have this here, it's 50 units per ml. So let's just come back here. I'm going to erase this so we have more room. And then I'm going to do 1,881 units per hour. And now we've got units per ml, and we want mLs per hour. So we're going to do this. We're going to flip this. Okay, so it's going to be 1 ml for 50 units. So we'll cross out units on both sides. And now we need to do 1881 divided by 50. We're going to get 37.62. Okay, or 37.6 or 38. Okay, and all that's going to be is mLs per hour. Okay, if they want minutes, we have to take 38 mils per hour and convert hours to minutes. We'll be multiplying it by 60, but usually this is enough. If you show your math, they're going to be fine with it. Okay. All right, so here we've got a patient weighs 450 pounds, receiving a heparin drip at 13 units per kilogram per hour. The standard mix, what rate will be set on the infusion pump? So we're going to say mLs per hour. We're going to set it for that. Okay. So there's your infusion. That's what the patient weighs. We have to let's do the patient first. So they're 450 pounds times 1 kilogram over 2.2 pounds. LBS. There we go. So it's 450 divided by 2.2. You're going to get 204.5454545454 forever and ever. Okay. So let's just say 204.55. Or this is an adult, they're 450 pounds. Let's just do 204.5. Okay, so that's how much they weigh. And we're giving 13 units per kilogram per hour. Okay, so let's look at the rate. I'm going to say 13 units per kilogram. Okay, and so we're going to go times 204.5 kilograms, because that's how much they weigh. So you take 204.5 times 13. 204.5 times 13. That's going to give you a ghastly number, 2,658.5, and that's going to be units. Okay, and because we've gotten rid of kilograms, that's going to be per hour. So that's what we're starting with, units per hour. Now we need to look at what we have. Okay, this is the dose. This is what you're actually giving. This is what we've converted from this, and this is your dose. Okay, but you got it in units per hour. We want milliliters per hour. So you have 25,000 units divided by 500 milliliters. And we're giving 2,658.5 units per hour. Okay, well, you know what? Let's start this. Let's do this a little bit different. Let's take the rate. Okay, and so I'm gonna, let's see, we'll just try to do this. 2,658.5 units per hour times, and then we need to flip this so we can get milliliters per hour. So let's go 500 milliliters over 25,000 units. We can cross out units, okay? And so we can also cross two of these out, okay? Two of them. So now we've got 5 over 250, which could be, you could just say 50, but it might make your math a little easier. But let's just take 2,658.5 times 5, and let's divide that by 250. And what we get is 53.17. Okay, and that would be 53.2 or 53. Okay, and that would be milliliters per hour. Okay, if you show your work like this on a paper test, they cannot do you wrong. Okay, you won't go wrong, I should say. All right, so this is what you have. This is what you're infusing. What will be set on the pump? This is a very easy question. So start with what you're infusing. You're already infusing. They know what, you know, you're not changing the final outcome. You're giving 3.2 milligrams per minute. Okay, and we have 500 milligrams over 250 mLs. So let's get what we, you know, when we say what's going to be on here, let's say milliliters per hour. Okay, that's the easiest way to do that. So let's go here and say 60 minutes is 1 hour. And then let's put these guys in here. Let's plug them in here. This is 500 milligrams in 250 mLs. So let's flip that. See, we got rid of minutes here. Let's flip that so that milligrams get canceled out. So let's go 250 mLs divided by 500 milligrams. So we can cross out the milligrams, and we can also cross out one of these zeros. Okay, and we can do the math. Okay, we can get the calculator out and say, okay, 3.2 times 60 times 25 is equal to 4,800. Okay, 4,000, or yeah, $4,800. 4,800, and you want to divide it by 50. Okay, so we can cross another one out, and we could say 480 divided by 5 is equal to 96. Okay, so that's 96 milliliters per hour, and that's your answer right there. Now let's go back and look at this a minute. We knew we were giving 3.2 milligrams per minute here. That's the rate. Okay, the rate, the flow rate. And then we have time conversion, minutes to hours. Okay, and then we have what we have. Okay, we had 500 over 250, but in order to cancel out the milligrams, we have to flip this. So it's 250 milliliters over 500 milligrams. And then you just do the math. You cross out the things that are the same on both sides. You do the math and you get 96 milliliters per hour. If you need minutes, then don't do this step here, this time step. It'll be ghastly though per minute. Well, I don't know. No, it won't be actually. 96 divided by 60. It would be a smaller number, but it doesn't matter. Okay, amiodarone, 500 and 250. So we have 500 milligrams in 250 mLs. We're infusing at 6.5 milligrams per minute. What are we going to do? Okay, what's the rate set on the infusion pump? Well, let's just keep things the same. Okay, so we're going to start with the rate, 6.5 milligrams per minute. We're not going to do any time changes. Okay, we're going to take this and we're going to cancel out milligrams. We have 500 milligrams in 250 mils. Okay, we'll cross out these guys. And we can even cross this out. We got 25 over 50, which is going to be 1/2. Okay, or 6.5 divided by 2. Very simple. Or you could leave it like it is and do it all out just in case, because you might be paranoid, especially if you're taking a test and you're nervous. But 6.5 times 25 divided by 50 is 3.25. Okay, so it's basically 6 divided by 2, because you think 25 divided by 50 is 1/2. So that would be 3.25. And that would be milliliters per minute. Okay, if we want hours, we could do 3.25 or 3.3. Okay, milliliters per minute, and convert minutes, 60 minutes, to hours. Okay, and that would be 3.25 times 60, which is 195 mLs per hour. Okay, and that's your answer, or that's your answer, or it could be 3.3 mLs per minute. Okay, that's also a correct answer. All of these are correct answers. 250 ml or milligrams in 100 mils. Infusing at 7.2, what rate will be on the pump? Same thing. Start with the rate when you've got something like this. What rate on the pump? 7.2 milligrams per minute times what we got up here. We want to get rid of these milligrams. So we're going to do 250 down here, milligrams, and then we're going to do 100 mLs above it. Cross out the milligrams, and we've got 7.2 times 100 divided by 250. Okay, 7.2 times 100 divided by 250, which is going to be 2.88. And that would be milliliters per minute. Okay, or it could be 2.9, or it could be 3, going a whole number. Okay, but it's all milliliters per minute. And so you can take that if you want more, if you want hours, 3 milliliters per minute times 60 minutes per hour. That's going to be 180 milliliters per hour. Okay, so this is correct, and this is correct, depending on what you want. You want hours, you want minutes. It doesn't specify on here. So I wouldn't convert to hours unless they ask you for it. Okay, don't read too much into your questions. Now we have 250 and 100. Okay, that's what you have. 250 milligrams in 100 mils. You are giving it at this rate, and you want to know what rate to put on the infusion pump. Start with the rate, 4.3 milligrams per minute. And so now we're going to get rid of milligrams. We're going to go 250 milligrams, and we're going to put 100 mils at the top. Okay, and so we can cross that out, and we can say, okay, 10 divided by 25. Don't do that. Keep your mind sane. That would be 43 over 25, because remember, 4.3 times 10 is going to be 43. We move it over 1 decimal place. Divided by 25. And we get 43 divided by 25, which is 1.72. 1.72 milliliters per minute, okay, or 1.7 milliliters per minute, or 2 milliliters per minute. Okay, if you have to do hours, just multiply whichever one you want. All these are correct answers. Multiply it by 60 minutes over an hour, and then you've got your hourly rate. Okay, and now we're going to do 500 over 250. Okay, 500 milligrams over 250 mils. We got a rate over here. Patient weighs 97 pounds, but we don't care because there's no weight-based. Not weight-based. Okay, this is your rate right here. And what you want to know is how many, oh yeah, it is weight-based. That was a mistake. Okay, we do care. We're looking at the answer. How many micrograms per kilogram per minute is this patient receiving? So we do need to care about this. 97 pounds. So we start with the patient. Let's get all our pieces together. Is equal to 97 pounds times 2.2 pounds underneath 1 kilogram, which is going to be 97 divided by 2.2. Okay, 97 divided by 2.2, which is 44.09090909 forever and ever, which is going to be 44.1 kilograms. That's how much they weigh. Okay, we're giving 6.2 milliliters per hour. Okay, so the infusion flow is going to be 6.2 milliliters per hour. Okay, we know we're getting this much per this much. We could actually make this easier by calling this 2 milligrams per ml. But to do, and we can actually do this. Okay, so we'll go 2 milligrams per ml. We cross out the mLs and we get 6.2 times 2, which is going to be 12.4 milligrams per hour. Okay, we're still far away. We need to figure out, this is actually the rate. So we have to also convert this to micrograms. So we can do this by going 1,000 micrograms in a milligrams. We cross out the milligrams and we're going to get 12,400 micrograms. Oops. All right, let's do that. Micrograms. That's micrograms per hour. Okay, per 1 hour. So we're still going here. We want to know how much we're giving to this patient. So we're actually giving a total of 12,400 micrograms per hour. So let's start with 12,400 micrograms per hour. Okay, per hour. And then we're going to do the weight. Okay, this is per kilogram. Let's ignore the time for a minute. Okay, we need to figure out how many micrograms per kilogram. So we're giving a total of 12,400. So we're going to divide that by 44.1 kilograms. Okay, and that's going to be, let's see what it's going to be here. 12,400 divided by 44.1 is going to be 281.179138, blah, blah, blah. Okay, so 281 point, let's say 2. Okay, we don't need all those other numbers, but that's what we're going to get. This is micrograms, and it's going to be per hour. Okay, so this is micrograms per hour. We've already taken into consideration how much the patient weighs. Okay, this is the weight. Micrograms per kilogram, and now we need minutes. Okay, so we're going to do this, and we're going to go 1 hour divided by 60 minutes. Okay, and so we're going to do 281.2, and remember, when you've got those crazy numbers, go ahead and round them, but don't use the original number in your calculator. You'll get a different number. So it's 281.2. I mean, use your rounded number when you're doing that. Time, oh no, it's going to be divided by, oops, okay, let's do this. 281.2 divided by 60, and that's going to be, let's see, minutes, hours, we can get rid of that. It's going to be 4.6866667, okay, 6866 forever and ever. Okay, so that one's going to be 4.7 micrograms per kilogram per minute. Okay, all right, so we'll get on to this next one. And now we're going to do nitroprusside or nipride. And we know we've got 250 over 250, so that's 1 milligram per ml. This is what you have. Okay, and we're running it at 5.4 mils per hour. Okay, that's the rate. That's what we're actually giving the patient right now. This is what the patient weighs. We do have to care because this is what we want. We need to focus on getting that kind of an answer. So let's start with the rate. We're going to go 5.4 milliliters per hour. Okay, and then we're going to look at what we have as far as I guess 130. Maybe we should do the patient. Let's do the patient weight first. That's going to be 135 divided by 2.2, which is going to be, let's see, I'm going to do that. Okay. 135 divided by 2.2. And that's going to be 61.4. 61.363636 forever and ever. So that's going to be 61.4 kilograms. That's what the patient weighs. Now let's get this into milligrams per hour and such, so we can figure out how many micrograms per kilogram this person is getting. So we're getting 5.4 milliliters per hour. We look at what we have, and we're going to do 1 milligram over 1 ml. We're going to cross out the mLs, and we actually have 5.4 milligrams per hour. Okay, we want to convert that to micrograms. Remember, when we do that, we multiply it by 1,000. But this, let's not skip steps. Let's do 1,000 micrograms in 1 milligram. So we cross out the milligrams, and we're going to get 5,400 micrograms per hour. Okay, so we'll keep it small for now. Let's figure out how many micrograms. This is actually what's going into the patient. So what we want to do is take this number and divide it by how much the patient weighs in kilograms to get micrograms per kilogram. So let's do that. 5,400 micrograms per hour times, and we're going to say, or excuse me, I did that again. Let's do this. Divided by, this is how much we're getting. We're giving this much. Okay, this is actually going into the patient. And so we want to divide it by the patient's weight in kilograms so we can get micrograms per kilogram. Okay, so that's micrograms per kilogram. And that's going to be 5,400 divided by 61.4. Okay, and that's going to be 87.947, blah, 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 blah. So let's just keep two numbers here. We're going to say 5 because 7 is high. So we're going to say this is micrograms per kilogram. Okay, but we're still talking about hours here. So we have to get this per hour. All right, so now we need to convert to minutes because we need minutes right here. So we're going to go 1 hour divided by 60 minutes. And that's going to be, we cross this out. Okay. We have 87.98, and this is one of the times when you want to not have the unrounded number. So go 87.95 divided by 60, which is 1.465833333333. So we go 1.465, which is actually 1.47 or 1.5. Okay, so we rounded here. Round it up for that reason. With this one, we round up again. So this is your micrograms per kilogram per minute. Okay, so that's your answer for that one. Okay, and now we're going to do this one, different kind. This is one of the questions that you were given to practice with. We have 1 gram and 500 milliliters. Okay, so that's 1 gram and 500 milliliters. That's what you have. And you're and this is your rate. Okay, your rate is 3 milligrams per minute. What do we want to set the infusion pump to? So we want milliliters per hour. Okay, this is what we're aiming for. This is what we have, and this is what we're starting with. So let's start with the rate. 3 milligrams per minute. Okay, remember we want to pay attention to that the most. 3 milligrams per minute. And these guys are going to have to be, we have to change this one as well, because in 1 milligram, see, let's do this. Let's say 1,000 milligrams in 500 milliliters. Okay. What I did right here is remember that 1 gram is equal to 1,000 milligrams. And that's all I did here was convert this. Okay. So now we want to go here and go, all right, 500 milliliters divided by 1,000 milligrams. Now I did this conversion because now we can cross these guys out. So we've got milliliters per minute. We need milliliters per hour. All right, 60 minutes divided by 1 hour. Now we cross out the minutes, and now we have milliliters. That's milliliters per hour, and that's what we want. So we just go through here. We can cross out some zeros on both sides as long as we do it on both sides. So we've got 3 times 5 times 6 divided by 1. Okay, 3 times 5 times 6 divided by 1. So 3 times 5 times 6 is 90. Okay, 90 mLs per hour. So that's your answer there, and that's your answer. And the next one we get here, we've got nitride. This is what we have here, 500 and 250. We're giving it for a patient who weighs 125 pounds. How many mils per hour do we want? So that's what we're aiming for. Okay, we want that. So 125 divided by 2.2 is going to be kilograms, right? 125 pounds divided by 2.2 pounds. So we go 125 divided by 2.2, and that's going to give us 56.81818181. So we're going to go 56.82. We can do that, or we can just say 56.8. So that's how much they weigh in kilograms. And now we're giving it at, we start with this rate, we're giving 2 micrograms per kilogram. Okay, so we need to do times 56.82 or 8 kilograms. We can cancel kilograms on both sides. So then we're going to multiply 56.82 by 2. Okay, 56.82 times 2 is 113.64, and that's micrograms. Micrograms per minute. Okay, because minute is what we start with. We had 2 micrograms per kilogram per minute. We just multiplied it by the kilograms over here, okay, or over here. And now we've got micrograms per minute. What we want is milliliters per hour, though, right? So we need to do what we have here. So we've got 500 milligrams per 250 mLs. Okay, 250 and 250 is 500, right? So that would be equal to 2 milligrams per ml. This makes our math easier. So we take this 113.64 micrograms per minute, and we need to get milliliters per hour. Okay, so let's figure out what we have here. To get micrograms with this one, we're going to have to say 2,000 micrograms per ml. Okay, and we want mLs at the top. So let's put 1 ml divided by, and we're using this up here because that's what we have. It's going to be 2,000 micrograms. Now we can cross out the micrograms, and we've got 113.64 divided by 2,000. And what we get is a crazy small number, but we still need hours. Okay, so let's keep going. Let's do this, and let's go. Okay, 60 minutes, because we need hours. Okay, we need hours up here. Hours. So we have 60 minutes divided by 1 hour. So we can get rid of minutes here, get rid of minutes there. So now we've got mils per hour. This is what we want, mils per hour. It's exactly what we got up here. So these number might be easier. We'll cross out 1 0 here and 1 0 here. So this will actually be an easier number. So 113.64 times 6 divided by 200. And what you get out of that is going to be 3.4092, which is 3.41. It could be 41, or it could be 3.4. And that's your answer. That's how many milliliters per hour you want to do. And so to recap on this one, we started out with the rate. Okay, this is the rate right here. We started out with the rate, and we multiplied it by the weight of the patient in kilograms, which we figured out here to be 56.82 or 56.8. And we got 113. This is the weight of the patient. So we take the weight and we divide it by, let's see, yep, we take the weight, see, micrograms per minute. So the weight got canceled out on both sides. So this is micrograms per minute. This is weight-based. Okay, sorry. So this is micrograms per minute, because up here is minutes. So that's micrograms per minute. So we take 113.64 micrograms per minute, and we multiply it by what we have. And we decided here with 500 milligrams and 250. 250 times 2 is 500. So we'd have 2 milligrams per mil. When we want to convert to micrograms, we multiply that by 1,000. So we got 2,000 micrograms in 1 milliliter. So we flipped that so we could cancel out the micrograms. And that's why, and then we needed hours, not minutes, because that's what they're asking here. So we did 60 minutes per hour. We canceled out all the things that were the same on both sides, and we simplified our math, and this is our answer right here. Also, the answer could be 3. If we're doing a single answer, this would be 3 mLs per hour. Okay. So next one we're going to do. 1 gram, this is what we have. 1 gram in 500 milliliters. Okay, we're infusing it at 20 ml per hour, and we want to know how many milliliters per hour we're going to be giving. Okay, so the infusion is 20 milligrams per hour. What you have is 1 gram in 500. Okay, so that would be 1,000 milligrams in 500 mils. Okay, and to see that, remember that 1 gram is equal to 1,000 milligrams. Okay, that's the conversion factor. So we take 1 gram over 500 and we get 1 gram or 1,000 milligrams over 500. You could actually just save that and say 2 milligrams per ml. This is easier to do. We kill that. 10 divided by 5 is 2. It's easy. What we want is milliliters per hour. We've got hour down here. We need milliliters. So let's flip this over here and do 1 ml divided by 2 milligrams. Okay, so we kill the milligrams, and we've got 20 divided by 2, which is 10 milliliters per hour, and that's your answer. All right. And the next one we're going to do is 4 grams in 1 liter. Okay, that's what you have here, 4 grams in 1 liter. You're giving it at 3 milligrams per minute, and you want milliliters per hour. Okay. So let's see what we have. 4 grams in 1 liter. That could easily go to 4,000 milligrams in 1,000 milliliters. Remember, 1,000, 1 liter is equal to 1,000 milliliters, and 1 gram is equal to 1,000 milligrams. So that's what we're just going to do that. And that could actually be, we could cancel these 3 and cancel these 3 and say, okay, it's 4 milligrams per ml. That's your simplest form of what this is your rate. Okay, this is what you're actually giving to the patient. So we have this rate, and this is what we have. And so we'll start with 3 milligrams per minute. Okay, times, now we know 4 milligrams per ml. So let's flip that. So we have mLs at the top, 4 milligrams, and we need hours. So we're going to go 60 minutes for 1 hour. So we've got hours here and we've got milliliters here. That's what we want, these two, so we can get that. So let's start crossing things out. Milligrams and minutes are gone, so this is good. Okay, so we've got 60 times 3 divided by 4. Okay, 60 times 3 divided by 4 is going to be 45. Okay, that is 45 milliliters per hour. Okay, and that's your answer. The next one we're going to do is 250 and 500, and the rate is 4 milligrams per hour, and we want to know how many milliliters volume per hour we need to infuse. So let's take what we have here, this business right here. We're going to go 250 milligrams in 500 mLs, and we're going to, we need milligrams, we got mLs. That's perfect, actually. We don't have to do anything with that. Okay, so let's go with the rate, 4 milligrams per hour. Okay, we know we want hours, which is good, so we don't need to check that. We know what we, and here we have our what we have. Okay, our rate, the amount we have. So we have to flip this so that we can get mLs at the top. Okay, so we're going to go 5 times 500 over 250, or you could just say, with 250 over 500, that would be 0.5 milligrams per ml. That's another simpler way to do it. But let's just do it this way. Okay, 500 mLs over 250 milligrams. So we're going to cross out the milligrams. And that would get us 4 times 500 or 4 times 50. Just do it that way. 4 times 50 divided by 25, which is 8. Okay, that's going to be 8 milliliters per hour. All right. So now we're going to do this one. 6 micrograms per minute is the rate. We want milliliters per hour. We need to know how much to set the infusion pump to. And what we have is 4 milligrams in 500 milliliters. Very simple, except we want micrograms. We need to have those to be the same. So that's going to be 4,000 micrograms in 500 milliliters. Simplified, you can cross out 2 zeros, and what you get is 40 over 5, which is 8 micrograms per ml. Okay, 40 divided by 5 is 8, and that's micrograms per ml. So that's what you have. So let's look at your rate. 6 micrograms per minute, and you want milliliters per hour. So let's go ahead and go 60 minutes per hour. Cross out the minutes, we've got hours. And now we need milliliters. So what we have over here is 8 micrograms per ml. So we're going to go ml divided by 8 micrograms. We can cross out the micrograms. So here we've got 360 milliliters divided by 8 hours. Okay, so 360 divided by 8 is going to be 45. Okay. So that's going to be equal to 45 milliliters per hour. And we got another one here. It's going to be, this is what we have. At 60 mics per kg per minute. We got a patient who weighs 150 pounds. 150 pounds divided by 2.2 pounds is going to be equal to 68.18 kilograms. So that's what the patient weighs. Okay, we're infusing it, or at this we have 6 micrograms, micrograms per kilogram. So we're going to multiply it by kilograms. 68.18 kilograms. Cross out the kilograms. So then we do 68.18 times 6, and we get 409.08. 409.08, and that's going to be micrograms per minute. Okay, and we get minutes from up here. This is the infusion rate. We're going to ignore minutes for a second. We're going to get the kilograms. So this is actually how much we're giving per kilogram to this patient per minute. And so now we need to do milliliters per hour. And this is what we have over here. We have 500 milligrams in 0.5 liters. You can always do that and say over 500 milliliters. Okay, 0.5 liters is going to be 0.5, 1, 2, 3. Okay, so that's equal to 500 milliliters. So we do that. We can do that. We can say 1 milligram over 1 milliliter. Okay, so that's 1 milligram per mil. And that's what you have in the bag that you're hanging. So we start with this and we go 409.08 micrograms per minute. Okay, and we want milliliters per hour, so we got to keep our eye on this one. Okay, times, and let's get rid of micrograms. So we got milligrams per mil, but we know that 1 milligram is equal to 1,000 micrograms. Okay, so we can say 1 milliliter divided by 1,000 micrograms. Okay, because of this, because we simplified it and we know this, we can say this and we flip it so that we can cross out these micrograms. And so now we've got 409.8 divided by 100, which you remember is going to go 1, 2, 3. So that's going to be 0.40908 milliliters per minute. Well, now we've got to do times 60 to get hours. Okay, so minutes over hours. We're going to cross out minutes this way. So let's take that crazy number. It's going to be 0.40908 times 60, which is going to give you 24.54. Okay, equals 24.54, or 24.5, or 25. And this, the correct answer that was given for this is 24 mils per hour, but it doesn't round that way. Even when we take the numbers and do it in a different way, so that the answer is not correct. But 25 mils per hour is your answer, or it could be 24.54 or 24.5. If you show your work on your test, they'll give you credit for it. So don't worry about that. Okay, 300 milligrams and 250. The rate is this much and the patient weighs this much. We don't have to do any conversions for that weight, but this is what we need to pay attention to. We want milliliters per hour. Okay, so let's look at what we have. We have 300 milligrams and 250 milliliters. We need micrograms. So let's see what we can do with that. Okay, that kind of gives you 6/5. Okay, this is going to be 6/5 milligrams per mil. Okay, and then you're going to have to get to micrograms. So so we go times 1,000 micrograms over 1 milligram. We cross out the milligrams. So that's 6,000 divided by 5, which is going to give you 1,200. Okay, so that's 12. Let me do this better. 1,200 micrograms per ml. Okay, that's what you have. Okay, have is up here. And that's what this is. Okay, that's what you have there. Your rate. Okay, we start with the rate. We know that this 85 kilograms, that's perfect because we don't have to do any conversions there. The rate is 2 micrograms. Oops, let me fix that. Micrograms per kilogram. Okay, per minute. We're going to ignore minutes for a second. So we're going to go times 85. Okay, kilograms. So we cross out the kilograms and we get 85 times 2. That's 170 micrograms. Okay, 85 times 2, 2 times 8 is 16, and then half of that is plus 1. So that's going to be, I just want to check myself, 85 times 2 is 170 micrograms. Now we're going to get our minutes back, micrograms per minute. Okay, so we take that, we're going to add it. So we know we're giving 170 micrograms per minute based on this weight here. And so what we want still is milliliters per hour. So let's start with this rate, 170 micrograms per minute, and times, and then we'll look at what we have up here. This is what we have. So let's get milliliters up here. This is micrograms per minute. So let me make that look more clear. Minute. Okay. 1 milliliter and 1,200 micrograms. Cross out the micrograms. We still need hours. So let's go ahead and do 60 minutes divided by 1 hour. Cross out the minutes, and we can do this. Okay, we got 170 times 60. You don't have to be fancy. Go 170 times 60 divided by 1,200, and we get 8.5. Okay, 8.5, and that's going to be milliliters per hour. Okay, and that's because we have this here, we have this here. So this is actually the amount we're giving, and micrograms per minute. That's the rate that we did when we figured with the weight. And then this is what you have. And this is a time conversion. And this would be minutes to hours. Okay, and that's how we got milliliters per hour. And this is the correct answer. Or you could just say 9 milliliters per hour, okay, which is the correct answer they gave. All right, next, 100 units regular insulin and 250, infusing at 12 units per hour. Okay, so what we have, let's look at what we have. We have 100 units in 250 milliliters. And we're giving, let's see, infusion is going to be 12 units per hour. Okay, what we want to know is how many milliliters per hour. Okay, this is what we want right here. So we're going to go X milliliters per hour is equal to, now let's look at what we got. Start with what you're giving and what you know to be true. This is just the dependent variable. This is what you have in the bag. It's not going to change. This is the thing that changes. Okay, so let's go 12 units per hour. We want milliliters per hour, right? So let's take this and flip it. Okay, we're going to go 250 milliliters over 100 units. We can cross units out. Voila, we've got milliliters right here and we got hours right here. All we have to do is multiply this out. Okay, so we take 12, and if you're nervous, like I said, don't do anything fancy. Just do 12 times 250 equals 3,000 divided by 100 is equal to 30. Okay, so that is 30 mLs per hour. Okay, we've done the hour up here. That's the time, and that's what we have here. And this was crossed out because so that's the correct answer, 30 milliliters per hour. So now let's do another one. 1,000 units of heparin and 500 milliliters. We're infusing it 100 per hour. We want to know how many mils per hour. Okay, so we have in the bag, in the IV bag, we have 10,000 units and 500 milliliters. We're infusing it at 10 units per hour, and we want to know milliliters per hour. Okay, so let's start with the rate. And we're going to go 100 units per hour. Okay, and what we have here, we have to flip because we want to get rid of units. So we go 500 milliliters and 10,000 units. So we can cross out units. We've got mils per hour, which is what we have up here, so we're happy. We can cross out a bunch of things. We want 1, 2, 3, and 4. Okay, so now we've just got 5 milliliters per hour, and that's the answer, y'all. If you start, if you do one zero at a time, you can cross out all of this busyness, and you get 5 milliliters per hour. Aminophylline, 2 grams in 1 liter of D5W, infusing at 0.4 of a milligram per kilogram per hour. Patient weighs 55 kilograms. What we want is milliliters per hour. What are we going to set the pump to? Okay, so let's look at what we have. We have 2 grams. Let me start over. I'm going to start over and do it over here. Okay, this is what we have. We have 2 grams in 1 liter. Okay, and you could do 2,000 milligrams and 1,000 milliliters. Okay, so now we've done that. We just multiply both of them by 1,000 because remember, 1 gram is equal to 1,000 milligrams and 1 liter is equal to 1,000 milliliters. So that's what we have here. And we can cross these out on both sides, and that's 2 milligrams per mil. Okay, you can do that in your head eventually when you get used to this. 2 milligrams per mil. So now let's look at the rate. Okay, we're getting 0.4 milligrams per kilogram. Okay, we know the person is 55 kilograms, so let's get rid of that. 55 kilograms. So we'll kill out these, kill out the kilograms. We go 55 times 0.4. Okay, 55 times 0.4. It's going to be 22. It's 22 milligrams. And now we get the time back. This is hours, milligrams per hour. Okay, because remember, we got this is the rate. So we wanted to get milligrams per kilogram first, and now we've got milligrams per hour, and that's our rate. What we want, though, is milliliters per hour. We've got hours, but we just need milligrams. So this is very simple. We can just take 22 milligrams per hour, okay, equals, and flip this. This is what we have, and this is our rate, okay? This is have right here, and this is the rate. Okay, so we take the rate and multiply it by what we have. So that would be times, and we want milliliters over hours. We got hours at the bottom. So we're going to go mLs divided by 2 milligrams. And so we cross out milligrams. 22 divided by 2 is 11 milliliters per hour. Okay, and that's your answer. It's the correct answer. Nitroglycerin, 50 and 250. Okay, we want micrograms per kilogram per minute. We've got a 50 kilogram patient. And we want the answer to be in milliliters per hour. Okay, so let's look at what we have. Okay, 50 milligrams and 250 milliliters. Okay, we could do some shortening of that, but let's just look at that and see what we have. And then we have we're going to start with 3 milligrams per kilogram. Okay, we look at part of the rate here. 3 micrograms per kilogram. We know we have 50 kilograms here times 50 kilograms. Okay, so 3 times 50 is going to be 150, right? 150 micrograms. And now we get the minutes back per minute. Okay, so we did this part. We got and we got rid of kilograms because we figured out how much we're given here. So we're giving it 150 milligrams or micrograms per minute. And we still have some work to do on that because we need to get milliliters per hour. Okay, so let's start with our rate here. We're going to say 150 micrograms per minute. Okay, we want hours. So we're going to go 60 minutes per hour. So that's what we want here. We can cross that out and cross that out. And now this is going to be funky because we need to, we need to do this better. So let's do this. Let's see. All right. So we'll cross out this. We'll cross out that. We're going to get 1/5. Okay. So that's going to be 0.2 milligrams per ml. How did I get that? Well, I crossed out the zeros, and you know that 5 times 5 is 25. 1/5, 1 divided by 5 is going to be 0.2. Okay, but this is still in milligrams. The reason why I did this is because we need to get it in micrograms. So we need to do this, okay? Micrograms, we're going to do times 1 milligram underneath 1,000 micrograms, okay? And so that, we can cross that out. We can cross that out. We've got 2 times 1,000, or 0.2 times 1,000. 0.2 times 1,000 is going to be 1, 2, 3. Add your zeros, which is 200. Okay, so that's 200 micrograms per ml. And that's what you have. Oops, sorry about that, y'all. This is what you have in your IV bag. Okay, that's what you have in your IV bag. And that's how we got to the numbers we need it to be. So we want mLs per hour as our final answer. And we've got hours down here, but we need mLs and we need to get rid of micrograms. So, and we did the conversion, so we could do that. So let's go mLs at the top. We'll flip it. And we'll go 200 micrograms. So cross out the micrograms. And you've got, and we can cross out a 0 here. And you can cross out another 0 here. And so you've got 15 times 6 divided by 2, or 15 times 3. Okay, because 6 times 3 is 2. 15 times 3 is 45, right? 45, and you don't even need a calculator for that one. mLs per hour. Okay, we have mLs here, and we have hours here, and that's what your answer is. Okie doke. We're getting through them. We're almost 7 more questions. All right, so we look at what we have here on this one. We have 250 and 250 to infuse at 5 micrograms per kilogram per minute. We have a patient who weighs 85 kilograms, and we want it to be in milliliters per hour. Okay, we have old pumps, pumps that can't think like the new ones can. So what do we have here? We have 250 and 250, which is going to be 1. Okay, 1 milligram per ml. Okay, and so we could also say times, because we went micrograms, we're going to say 1 milligram underneath 1,000 micrograms. And that's going to be equal 1,000 micrograms per ml. Okay, so that's what you have is 1,000 micrograms per ml. That's what's in your IV bag right here. Okay, all this business right here. So we start with the infusion, the rate. Okay, and we have, and remember the first part we're going to do is just 5 micrograms per kilogram. So we take 5 micrograms per kilogram times 85 kilograms. That's what they said it is, 85 kilograms. Cross out the kilograms. 85 times 5. 85 times 5 is 425. Okay, 425 micrograms. Now we're going to pay attention to the minutes. Excuse me, that's milligrams. I should do micrograms. And this is per minute. Okay, so this is what we have. And this is the rate that we have, the infusion rate. So now we're going to take the infusion rate and go 425 micrograms per minute. We want hours. So we're going to go 1 minute, 60 minutes. What's wrong with me? I've been doing these too long, I guess. All right, so 60 minutes in 1 hour. Okay, so we cross out, I'm going to make that a real HR here. Okay, so we cross out the minutes. We got micrograms per hour. Well, we need milliliters per hour. So we take what we have up here, okay, times what we have. We're going to flip it. So we have milliliters at the top, divided by 1,000 milligrams, micrograms. Let me fix that. Micrograms. That's the whole reason why we did this conversion. So this is micrograms. And we can cross out micrograms. We've crossed out minutes, and now we've got milliliters per hour, and we know we're going to get a good answer here. So we go 425 times 60 divided by 1,000. Okay, so 425 times 60 divided by 1,000 is going to be 25.5. Okay, 25.5, which is equal to 26 milliliters per hour. And that's what we did here. So that's your correct answer. Either 25.5 or 26 is going to be the correct answer. And now we have heparin, 25,000 and 250. Okay, so we have 25,000 units in 250 mLs. Now we could do this, okay, and we could see that that's going to be 25 times 100 is going to be that, so it's going to be 100 units per ml. Okay, infusing at 6 mils per hour. Okay, so infuse is going to be 6 milliliters per hour. How many units per hour? Okay, so what we want is units per hour. Okay, we've got mils per hour, and we've got what we have, which is units per ml. So let's just multiply it. Okay, 100 units per ml. And we can cross out mLs, and we get 100 times 6, which is 600. 600. 6 times 100 units per hour. Okay, and that's exactly the correct answer. 600 units per hour. We got a few more left to go. 6 more to go. Okay. We have insulin, 200 units in 500 mils. Okay, and that's what we have. We can cross that out, cross that out. We got 2/5, which is 0.4 units per ml. we're infusing at 25 mils per hour. We want to know how many units per hour the patient is receiving. Okay, so what we want is units per hour. Okay, so we have what we have, and then we have the rate. Okay, rate is 25 mLs per hour. And then we want to do 0.4 units per ml. Okay, we cross out the units or the mLs, and we have units per hour, which is exactly what we want. So we take 25 and we multiply it by 4/10. Okay, 25 times 0.4, and you get 10. So that is 10 units per hour. Okay, so we have hour here and we've got units here. Okay, all right, so we got the right answer. And the next one we're going to do, we have 50 milligrams and 250 mLs. Okay, that's what we have here. And so we could cross that out again, and we got 1/5, which is going to be 0.2 milligrams per mil. That's what we have in the bag. We're infusing the rate of 60 mLs per hour. What we want is milligrams per hour, not milligram or milliliters per hour. Okay, so we're infusing it that much. How many milligrams per hour is this person getting? So that's an easy one too. We just take the rate, milliliters per hour, multiply it by milligrams per mil. We don't even have to do this shortening, which I did here, but it's okay. 0.2 milligrams in 1 milliliter. We cross out milliliters, or we could do 50 over 250. It doesn't matter. They'll come out to be the same. 60.2 times 0.2 it's going to be 12. Okay, so that's 12 milligrams per hour. Okay, and that's the correct answer. And now we have, well, one of these questions has lots of stuff in it. Okay, we start with what we have, which is 2 grams. This is what we have here. This is the infusion rate. The safe dose is given as this, and this is how much the patient weighs, and we have to answer if it's a safe dose. Okay, so let's look at this a minute. Okay, what we have is 2,000 milligrams. We'll go ahead and just make that 2,000 milligrams over 1,000 mils, which is actually 2 milligrams per ml. That's what we have in the bag. We're infusing, okay, at the rate is going to be 22 mLs per hour. Okay, and so let's find out what kind of dose we have here. Okay, so we're given 22 mils per hour. We have 2 milligrams per mil, so let's go times 2 milligrams per ml, cross out the mLs, and we're actually giving 44 milligrams per hour with that bag that we're hanging there. Okay, so it's 44 milligrams per hour, and we say that the safe dose is 0.4 milligrams per kilogram per hour. So we take 44 and we divide it by 55. Okay, that's how much we want to know per kilogram, milligram per kilogram. So so let's look at this for a second. 0.4 milligrams. Let's see. Oh, that's the rate. Never mind. All right. So milligrams per hour. And so this is actually how much the patient's getting. Okay, because we took the rate. This is the infusion rate. And we multiplied what we have, and we got 44 milligrams per hour. Okay, so the question then is, what is the safe dosage? The safe dosage, safe, is 0.4 milligrams per kilogram. So that would be 55 kilograms. Okay, we can cross that out. And of course, we're going to say hour when we get to that. So we take 0.4 times 55, and we get 22. Okay, so we have 22 milligrams per hour. Okay, because hours up here, we're going to put the time back in here. We canceled out the kilogram. So that's the safe dose. This is what they're getting, is 44. This is the safe dose. Okay, so if we look at this, the client is actually getting twice as much as they should be getting. They're getting 44, they should be getting 22. So you would answer which IV is the IV dose at the present rate, flow rate safe? And the answer would be no, because they're getting twice as much, 2 times that the safe dose. Okay, I'm going to do another one like that. Okay, and it looks to me like this one is drug A. They just don't even care what the drug is. Okay, doesn't matter. Where do we need to do this? So, okay, we have 1 gram and 250 mLs. We got micrograms here. So let's go ahead and let's make this into milligrams at least. So we're going to go 1,000 milligrams in 250 milliliters. So what I did was convert this to 1,000 milligrams. Okay, and that's to make something a little bit easier here. The infusion rate is 14 milliliters per hour. The safe dose is 12.5. Okay, I'm going to take that out because I want to be able to see it. That's your safe dose. And this, this is what the patient weighs. So we take 165, divide it by 2.2, and that's how many kilograms we get. Okay, so that's going to be 165 divided by 2.2, which is 75 kilograms. Okay, so that's 75 kilograms. That's what the patient weighs. And this is what we have. Okay, we got 100. If we cross this out, we've got 100 over 25, which is actually 4 milligrams per mil. What the heck did I just do? Well, I crossed out the zeros, and you know that 25 times 4 is 100, right? So that's how we get 100 divided by 25. That's 4 milligrams per mil. So when we get to micrograms, it'll be easier because we have 1 milligram is equal to 1,000 micrograms. So we can just take this and go 4,000 micrograms per ml. That's what you have in the IV bag. Now, we have the rate. The rate is, okay, 14 milliliters per hour. Okay, so what do we have? We don't know. Is this a safe dose? We want to know micrograms per kg per minute. Okay, so we know we want to get to this to be able to tell if this is safe. So let's go 1 hour divided by 60 minutes. We can cross out hours. We got milliliters per minute. And now we have micrograms per mil. Okay, so let's flip that. Actually, let's not flip it. Let's go 4,000 micrograms per ml. Okay, cross out mLs here, cross out mLs here, a 0 here, and a 0 here. And we got 14 times 400 divided by 6. Okay, 14 times 400 divided by 6, which is 933, equal to 933.3333 forever. And that's going to be micrograms per minute. Okay, now we need to know, let's see, the rate. We need to divide it by 75. Okay, so we take 933.3 divided by 75 kilograms, because we want to know how many micrograms per kilogram per minute it is. So we need to know that. We need to divide that by 75 kilograms. So we go 933.33, or 0.3, excuse me, 933.3 divided by 75, and we're going to get 12.4. Okay, so that's 12.4, and that's going to be micrograms per kilogram per minute. Okay, the safe dose is 12.5. Well, you know, there could be a rounding error because this is a forever number here. Okay, so I would say yes, this is safe. Because you know, you do all this, we've done all this math, and we figured out how many milligrams or micrograms per kilogram per minute, And it pretty much is very, very, very close to 12.5 micrograms per kilogram. So the answer to this is yes. Okay, it's safe. And so here we go. This is the second to the last one. We're going to see what we have here. It's going to be 50,000 units of heparin in 250 milliliters of normal saline. We're infusing it at 6 mils per hour. We want to know if the infusion rate of 1,000 units per hour is safe. Or, I mean, excuse me, that's the safe rate is 1,000. Okay, so let's see, safe is 1,000 units per hour. Okay, we need to know if this is a safe dosage. So this is what we have. We can just start chipping away at that and make it a little bit easier. We'll say 5,000 divided by 25. That'll be a much easier number to do. That's going to be 200. Okay, 200 units per ml. That's what you have. Okay. And what your rate is 6 mLs per hour. Okay, so you got this times, and we got ml at the bottom, so let's just go 200 units over 1 ml, cross that out, and we've got, looks like 1,200 units per hour. Okay, so we're giving in 1,200 units. Remember that's a unit. That's 0, and that's units. So we have hours here and we have units here, and that's what we're looking at, units per hour. And we want to know if 1,000 units, if that's safe, and they're getting this. Okay, and say this one, that's safe over here. So 110 or 1,000 units per hour units is less than 1,200 units per hour. And so this is not safe because it's 200 units over. Okay, if that's the safe dose, this is safe, this is a safe dose. We're actually giving them 200 units per hour too much. So the answer here is going to be no. All right, it's not safe. And finally, the last one. All right, let's look at this. 200 units. Okay, 200. This is what we have. 200 units over 250 mLs. Okay, infusing at, the rate is 7 units per hour. Okay, so when you come on duty, the IV infuser, I wish they wouldn't do that. Just the infuser is set to 14 mils per hour. Is it set at the correct rate? What is the correct rate? So, so this is the rate it's actually being infused at. But the order is to infuse at 7 units. So the question is 7 units per hour the same thing as 14 milliliters per hour? And so let's look at that question. Okay, we got 20 over 5, which is 4/5, which is 0.8 units per ml. Okay, so that's what you have in the bag. It's running at 7 units per hour. So let's do this and flip it, and we'll say mLs, 0.8 units. Okay, so now we can cross out units. We got 7 divided by 0.8 is going to be 8.75. Okay, 8.75. That's how many mLs per hour this thing should be running at. Okay, or it could be 8.8, or it could be 9 mLs per hour. Okay, any of these. It's running at 14. Okay, it's running at 14. It should be 9. So the answer is no, not safe, because that's what's running. This is what the order is for. And actually, this is you know, the question is it the correct rate? And what is the correct rate? The correct rate is 9 milliliters per hour. Okay, that's the correct rate. So what we did here was we looked at what we had, and we got it down to the simplest thing that we could have, which is 0.8 units per mil. And then we looked at the rate that's actually infusing, and we did 7 units per hour times, and then we did what we have, milliliters over units, and we got 8.75 mils per hour. And then, of course, we could say 8.8 or 9 mils per hour, but that's actually what's running into the patient. And then if what's supposed to be running, this is the correct amount. Okay, it's not what's running in the patient. When you come on duty, the actual rate is 14 milliliters per hour. So is it set at the correct rate? The answer is no, it should be at 9, and the correct rate is 9 milliliters per hour. All right, well, good luck on your test, retake, and I expect everybody to pass. You've got this. Just talk yourself through this. Go through, don't skip steps unless you're super confident, but if you're on a test, it's even better not to skip steps that way either. Just take your time, you'll do good. I expect all of you to pass. Good luck.